Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 36 from the Smith Organic Chemistry textbook. And this problem is giving us 3 alkenes and then asking us a series of questions about these alkenes. And so I've drawn them here, A, B, and C. And so first we're asked to rank them from lowest heat of hydrogenation to highest heat of hydrogenation. And so remember, this question is really asking us about the stability of these alkenes. And so in order to determine that, we look at the substitution pattern. We see that A is monosubstituted, B is tetrasubstituted, and C is trisubstituted. And so based on that, we can make a pretty easy judgment. B is going to be the most stable because it's tetrasubstituted, and therefore it's going to have the lowest heat of hydrogenation. C, trisubstituted, is going to be slightly less stable than B, so its heat of hydrogenation will be slightly higher. And then A, monosubstituted, is going to be significantly less stable than B or C, and so it will have the highest heat of hydrogenation. So for part B of this question, we're asked to rank the same 3 molecules by their rate of reaction with H2 and palladium on carbon. So how quickly they would be hydrogenated. And so really this is just another way of phrasing the same question we were asking in part A. So the least stable molecule, the molecule that gives off the most energy when it is hydrogenated, is also going to be the most eager to be hydrogenated. And so the answer for part B is BCA again, because the speed of the hydrogenation reaction here should mirror the energy levels as measured by the delta H of hydrogenation. So again, for part B, the answer is BCA. And then for part C, we're asked to cleave each of these molecules with ozone, followed by zinc and water. And so remember, when we're doing an ozonalysis, you essentially just look at the molecule, and you can just draw a line through the double bond and just write what your products would be. So remember, with this workup conditions with zinc and water, we will get carbonyl molecules. And so for A, you can see I drew a line through the bond, and these are what we would get. We would get this aldehyde here, and we would get 1 molecule of formaldehyde. So then for B, B is actually a symmetrical molecule. So if we draw a line right through the double bond there, cut the molecule in half, we would get these 2 molecules, and they're actually the same molecule. If you were to flip one and then flip it across a mirror plane, it's actually the exact same molecule. And then for molecule C, for part C, if you draw a line through the double bond, again, you get these 2 molecules as your answer. So you get this ketone here, and you get this aldehyde. And so that is the answer to number 36.